Good morning, Knights. Welcome back to Chemistry Online. So this is going to be my second recording of this one. I had the same issue I had yesterday where audio was not working. So here we are. We're about to do it again. So it's going to be kind of short, kind of fast, just because I've already done it. So today we're going to be talking about covalent compounds. Covalent compounds are going to be elements. So it's going to be nonmetals bonded with other nonmetals. So I'm going to abbreviate that for NM for nonmetal. So nonmetal bonded with another nonmetal. That's going to be a covalent compound. We already talked about ionic compounds. Ionic compounds, they're going to be metals bonded with nonmetals. And the other type of bonding that we've already discussed a while back is going to be metallic bonding. And metallic bonding is going to be two metals, two or more metals. Today, though, we're going to be talking about covalent compounds. And covalent compounds are going to be nonmetals. That means they're going to be elements on this side of the periodic table bonded together. You can't have any metals in covalent compounds. It doesn't work. Hydrogen, which is over here, is included with these, though. So let's go ahead and move on. All right, so here's the rules to naming covalent compounds. So covalent compounds are made up of nonmetals. You should have written that at least one time somewhere on your paper. But the rules to naming them aren't that much different than ionic. So to name a covalent compound, first you're going to name the first element. So the first element, you're going to write out its name. Then you're going to name the second element, changing its ending to IDE. And then it says to use prefixes. So we're going to talk about prefixes in a second. But basically that's how you know how many of each element you have. All right, so here are our prefixes. So I'm pretty sure you know some of these, but there is a few that you don't know. So I know most people know that mono means one. Most of you know that di means two. Most of you know that tri means three. Tetra is where a lot of you get confused. So tetra, that's going to be 4. Penta, just think of pentagon, that's 5. Hexa, think of hexagon, that's 6. Hepta, think of heptagon, or is that a thing? I think of heptane. Octa, that's going to be an octagon. Nona is where a lot of people get confused. So nona is 9. And then deca, that's 10. That's it. These are your prefixes and you need to know them. Write every single one of them down because you're going to need these for all of your covalent compounds. So naming covalent compounds I think is easier than ionic, but I always start with the harder one first. So you already got the hard stuff. Now this is actually a lot easier than what we were doing before, and you'll see why in a minute. So another rule to keep in mind is that if you only have one of the first elements, you're not going to write mono. So the first element, you never use the prefix mono. Mono is only used on the second element. So let's go ahead and name this first one. So here we have one carbon, but we're not going to write monocarbon because you never use mono in the beginning. You never start a compound with mono, ever. So here we have carbon monoxide. That's that one. Next one we have is carbon, and that's going to be dioxide. Here we have phosphorus trichloride. Here we have carbon tetrafluoride. And then here we have dinitrogen monoxide. So if you have more than one of the first element, you need to put a prefix. So if you have 2, 3, 4, 5, and 6, you need a prefix. If it's just one, that's the only time you will not use a prefix on the first element. So I would write that mono is omitted from the first element. Never use it on the first element. All right, let's move forward. All right, so those are already answered for you. So diphosphorus, pentoxide, and then we have carbon tetrachloride, and then here we have disulfur, trioxide, and then we have nitrogen dioxide, And then we have carbon monoxide. And that's it. All right, so here's the really easy part. When we were talking about ionic compounds, it was a lot more difficult because you got to write in the charges and find out how many of each element you have. But when we're talking about covalent compounds, that's not necessary because they tell you how many of each element you have. So here we have dinitrogen, so we have 2 nitrogens. And then we have dioxide, which means we have 2 oxygens. Next one we have diphosphorus. And then heptoxide, so hept, that's going to be 7. And then here it says, do not reduce the subscripts for covalent compounds. So here we have 2 and 2. And if this were an ionic compound, we could reduce this to NO. But here, we're dealing with a different element. So that's going to be nitrogen monoxide, which is a different element than dinitrogen dioxide. So with covalent compounds, you're never going to reduce. So I would write that down somewhere too. So do not reduce subscripts for covalent compounds. That's going to be it here. All right, last thing we're going to talk about today are going to be the diatomic elements. And diatomic elements are elements that are never going to be found on their own. So an example of that's going to be oxygen. So you're never going to find a lone oxygen anywhere. And that's mostly because elements are found in combination, like you're going to find more than one of oxygen wherever you go. But when we're talking about these 7 elements, you're never going to find them isolated. They're always going to be in pairs until they bond with something else. So in the case of oxygen, it's going to be double bonded to another oxygen. Nitrogen is going to be triple bonded to another nitrogen. So you're never going to find them alone. They're always going to be in pairs until you separate them. Hydrogen is always going to be bonded with another hydrogen. Fluorine is always bonded with another fluorine. And that's basically what the diatomic elements are. They're elements that are always found in pairs. So these are them: iodine, bromine, chlorine, fluorine, oxygen, nitrogen, hydrogen. But I don't like teaching them that way. I like showing them to you on the periodic table. So here they are. You have nitrogen, you have oxygen, fluorine, chlorine, bromine, and iodine. That's how I remember them because they're all in a line. They make a 7 and you have 7 diatomic elements. Obviously these are not diatomic. You can find a helium by itself. You can find a helium by itself because it has all the valence electrons it needs and it's perfectly happy to be alone. But all these other ones, so oxygen has a -2 charge, which is why it's double bonded. Nitrogen has a -3 charge, which is why it's triple bonded. Hydrogen it's got a +1 charge, but it's the only one here with a positive charge, and that's why we keep it on the other side of the periodic table. But here we have a -1, -1, -1, and then -1. And because they have a charge, they bond with other things. They're not happy by themselves, so they bond to other things. The noble gases don't need to do that, so that's why they're excluded. But that's them. As you saw, it's these 7 elements right here: nitrogen, oxygen, fluorine, chlorine, bromine, iodine. These are the elements. Which one are we excluding? Oh, we're excluding hydrogen. Here's the last one. All right, and that's going to be where we stop today. If you have any questions, just save them for next time. I'm going to give you guys an assignment today. Hopefully it's covalent compounds only. And then in the future, I'm going to give you mixed nomenclature. So you're going to get ionic and covalent mixed together, and you're going to need to identify which rules you need to use to name them. But as for today, you're going to get covalent only. So have a good rest of your day. Enjoy your weekend, and be sure to get this assignment done before next class.